Good evening. I would like to deliver my talk on biodegradable detergents and its impact on environment and economy. All we know that's the fact that the basic traditional detergents, they have origin of a petroleum, and that origin is non-renewable. It has a huge impact on environment, negative impact, all, and it affects the economy because this is basically imported by a country like India. So these detergents we use in our day-to-day life, like shampoo, soaps, facial cleanser, washing liquid, car washing liquid, all these they fall in the category of detergents. Now, when you go through detergent chemical market analysis, right now in 2025, this market is of 74 billion US dollar. And this is going to reach to the demand of $110.65 billion by 2029. And this compounded annual growth rate for this particular requirement would be 10.5%. Now, this is a huge demand. When it comes to Indian currency, this demand is somewhere 65 lakh crore right now, and it would be reaching to 97 lakh crore by 2029. Now, detergent chemical market segment, there are by product, by application, and by region. Now, detergent chemical market share by product. So if you just see this slide, the majority, among this category of detergent chemicals, surfactant tops the list, and it is occupying the 32.35% requirement. Am I audible, ma'am?
Yes, you can continue.
Thanks a lot. So then when it comes to other demands like builders, enzymes, bleaching agent, fragrances, and others, among this, the major requirement is of a surfactant. Now, when we go by application, in this category specifically, household and commercial cleaning product, it is 22%, laundry cleaning product 21%. Thereafter, personal cleaning product 19%, dishwashing liquid 16%. Now, the countries which are using highest amount of detergent in their per capita consumption, among this, the list is being topped by North America, basically Mexico, Canada, and United States of America, and among other countries, that is, they are using the detergent to the level of 48%. The rest 20% is from Europe, then Asia Pacific 12%, Latin America 10%, Middle East Africa 10%. So North American region is displaying the significant opportunities for detergent market, and because of this huge consumption of detergent chemical in this region. Now, why there is a need for biodegradable, detergents? There are environmental concern, health and safety concern, competition, market saturation, raw material cost, regulatory compliances, consumer preferences, etc. and etc. Now, the word I'm going to touch the very basic component of detergent. What it has come from a Latin adjective detergens, from the verb deterger, meaning to wipe out or polish out. A detergent is a surfactant. It's a combination of a different products, but major component of a detergent is surfactant with some cleaning components. Detergent is sometimes why this is known as surfactant, because they decrease the surface tension of water. Surfactants are the chemicals which decreases the surface tension of water. What are detergents? Detergents are sodium salt of long chain benzene sulfonic acid or sodium salt of linear alkyl hydrogen sulfate. It consists of large ionic hydrocarbon group, non-ionic hydrocarbon group, and ionic sulfonates. And it has basically, there are two ends. One is the tail, another is head. Head is hydrophobic in nature and head is hydrophilic in nature. Now, category anionic detergent, cationic detergents, non-ionic detergent, and deuterionic detergent. There are various examples which are displayed on the screen. Now, what exactly is detergent? In the detergents, basically, major component is surfactant, and there are some builders, detergent builders. Normally, like dolomite, we mix it. We mix sodium tripolyphosphate. We mix sodium carbonate, sometimes sodium bicarbonate. These ingredients helps to reduce the hardness of water by binding with metal ions. All we know that even the water is hard, there should be a mechanism in the detergent which can suppress the hardness of water. We put certain bleaching agent also, and we put anti-soil redeposition agents like carboxymethyl cellulose. Once suppose when you clean the dirt from the cloth, then the same dirt should not refix to the cloth. To avoid this phenomena, we have to put anti-soil redeposition agent, and the popular agent which is being used is carboxymethyl cellulose. Now, these innovations, we know that there are innovations which are many chemicals are being replaced by enzymes, many builders are being replaced. Now, the next point is application of detergent, where it is used: household cleaning, industrial cleaning, personal care, environment and eco-friendly application. Traditional detergent often contain surfactant based on petroleum products like LABSA. What does it mean? Linear alkyl benzene sulfonic acid, phosphates and other chemical. Basically, these LABSA, phosphates and other chemicals, they have petroleum origin. And they are not replenishable sources. They are non-renewable. And they contribute, these particular chemicals like linear alkyl benzene sulfonic acid, phosphates and other chemicals, they contribute significantly to the water pollution, and thereby they cause a huge harm to the aquatic life also. The runoff from the detergent can lead to eutrophication in water bodies. What does this eutrophication means? Is a uncontrolled growth of algae, and this excessive growth of algae, they deplete the source of water bodies. May it be the free oxygen, may it be mineral. Then these water bodies are left with no mineral contents, and it is there would be a depletion of oxygen also. The next point is this results in oxygen depletion. Means what, the oxygen available within the water bodies is getting declined, and that leads to the death of fish and other marine organisms. It also contributes to foaming of water bodies. For instance, when we are using detergents and it finds its passes through particular sewage and then it enters to the water body, and that contributes to the huge amount of river foaming, water bodies foaming and ocean foaming. And this is a huge, this problem is dangerous problem, and that its root of these problems is basically use of petroleum origin surfactants and detergents. Now, why this topic has garnered support? Why this topic of biodegradable detergent is important? Because the traditional detergents has got certain disadvantages. First, it is, as far as biodegradation is concerned, it has a slow biodegradation. It leads to skin and eye irritation, resource intensive production, environmental persistent, and most importantly, aquatic toxicity. I was mentioning about the kind of harm to the aquatic flora and fauna, and potential groundwater contamination. When these detergents containing petroleum origin, they there would be these particular through soil contamination. They enter into the soil through water. They go to the soil, and from soil it enters to the inner strata of the soil, causing this groundwater contamination. So these are all serious problems. If you see point 1 to 1, 2, 3, 4, 5, 6, all these problems are very important, and these important negative impact of the particular is because of petroleum detergents only. Now, why the biodegradable polymer based detergents are important? Because basically it has low environmental impact, it is water soluble, it is renewable source material, non-toxic in nature, biocompatibility, surfactant efficiency, and performance. If you just see the advantages one by one, you will understand that This is very positive as far as environment is concerned. It is soluble in water. It has got renewable, because basically the raw material which we are going to use in this particular research, we have used in this research proposition the starch material that has come from basically agriculture origin. And the farmers are going to be largely benefited out of this particular research. Now, what are the key market drivers for biodegradable polymers? Growing consumer awareness, urbanization, technological advancement, and market differentiation. The interesting, this slide is very important. If you just go to the present consumption of biodegradable detergents in the global market, it is $8.86 billion, US billion dollars. In coming years, it is going to grow at the rate of 6.9% CAGR, compounded annual growth rate. And this demand is going to be touched to the extent of $11 billion by 2029. It has a huge business potential. Now, this particular research do conform to the philosophy of a green chemistry. The point number one in green chemistry is atom economy. Second, by using this biodegradable product, you are generating least amount of waste. Design for degradation. It is absolute 100% degradation. We are using catalyst, which is promoting the rate of reaction. And use of renewable feedstock. This is very important because the major raw material we are chosen for this research has come from the agriculture, basically starch, glycerol, dolomite. These are the components. His percentage, as we have taken it to 50% and 30%. Almost 80% biodegradable components are being chosen for this particular piece of research. Now, this enzyme catalyst that we are using protease, amylase, lipase, and cellulase, which will remove protein stains, then starch stains, then fat stains, which will prevent the fabric damage, etc. and etc. Now, how this detergent acts, how it removes the dirt which is there in the cloth. There are two basic components. For instance, I would like to quote an example of linear alkyl benzene sulfonate, a specific dodecyl benzene, sodium salt of dodecyl benzene sulfonate. There are two ends. One is hydrophilic end, another is hydrophobic. Now, when there is a dirt, now this hydrocarbon part of the dirt, hydrocarbon part of this particular soap, it captures the dust. And this hydrophilic, it is going to touch, take it to the fold, it is going to attract water. Now, this particular phenomena, it is like a critical micelle concentration, wherein a dirt is being captured through micelle formation of a soap. And after capturing the dirt, this dirt is taken out from the cloth. And we are taking precaution that this dirt should not refix to the cloth by putting anti-redeposition agent like carboxymethyl cellulose. Now, this unique chemical structure is being designed, and there is a big role of hydrophilic lipophilic balance. This is a very important parameters which decides whether a component or any material can be used as a detergent or not. That is the HLP parameter which qualifies. Now, enzyme catalyst, this point for sustainable detergent we are picking, they are biodegradable. Now, the subject under study is, biodegradable, phosphate-free, it reduces chemical waste, low energy consumption, fabric longevity, because when you use detergent, it should not disturb the life of cloth also. And manufacturing cost and low toxicity to aquatic life, that is flora and fauna. Now, research objective we have chosen, basically, since we have synthesized biodegradable polymers using agro-based material like starch, glyceride, and malic anhydride. Optimized synthesis parameters, polymer synthesis characteristics, physical chemical property, IR, NMR, and biodegradability. Formulate eco-friendly detergent with STP, the sodium tripolyphosphate, to the tune of 4.5%. In traditional detergent, that percentage goes to near about 40%. Now, this particular component is being replaced by dolomite from 8 to 26%. Now, start bed detergents are designed to be biodegradable, environment friendly. They break down more easily in the environment. They reduce long-term impact on ecosystem. Starch bed detergent can help mitigate pollution and promote sustainability. Now, the starch, one of the major component of our research, then dolomite. The synthesis of polymer, look at the starch. What we have done for this, 30.76% starch we have chosen. We have taken for this. Glycerol 53.84%, malic anhydride 15.38%. We have taken 1.53% of concentrated hydrochloric acid catalyst and water 92%. During this particular process, this is basically an esterification reaction. And this is the polymer which is displayed on the side is going to form after the reaction. And the formation of the OH stretching is reflected 3412 centimeter inverse, C double bond O stretching, CO stretch, alkane stretch. These particular stretches are being seen in the IR. It's proved that there is a formation of ester. Now this particular research, now the point is the polymer under discussion, whether it is biodegradable or not. We have the biodegradability of any polymer or any material is found. We have to find out the ratio of BOD to COD ratio. That is very important. Now the BOD to COD ratio of this particular polymer is found to be 0.6075. And the percentage of BOD ratio is above 0.6. That polymer is considered to be biodegradable in nature. Now the benefits, I'm going to cite these benefits on the slide. We have used very least amount of STPP, which has a petroleum origin. It leads to pollution. It leads to eutrophication. We have replaced it with dolomite, which is a biodegradable in nature. It is used as builder. It has an enhanced cleaning ability. We have used replaced petroleum surfactant with biodegradable polymer. Cost effective. This is very cost effective, eco-friendly, used for household cleaning and scalable for industrial use. Polymers are renewable and as well as the polymers are biodegradable. Now, this is a very important slide, whether the material which we have prepared can be used as a detergent or not. That is decided on the basis of HLB value, and the HLB value of our product is found to be 12.39, and the scale is visible when we have the 12.5 or something. From we start from 12 to 13, then that 12 to 13, and from 13 to 16, if the value is of HLB value is in this range from 13 to 16 or nearby that value, we can use it as the material for detergent synthesis. Now, exactly what we have done in this polymer, after preparing the polymer, we have converted that polymer into powder detergent, and we have made these samples like O11, O12, O13 and O14. You just look at the proportion of polymer: 8.33% polymer, 8.33% acid slurry, 50% sodium carbonate, EDTA 4.16, STPP 4.16, SLS 1.66, SLES 1.66, carboxymethyl cellulose 8.41, dolomite 8.3%. Now you look at the first composition itself, in which there is 50% sodium carbonate. And sodium tripolyphosphate, we have kept it to the minimum level, where in most of the tradition it goes to 20%, 25%, somewhere in 30% also. Now we have kept this percentage. We have subsequently increased the percentage of a dolomite, very cheap and very effective builder. We have increased this percentage to 26.66. Now there is physicochemical properties, and this O11, O12, O13, O14, a pH value 9, 11, 12, 12. This entire pH value, as you just look at the side, it goes in the direction of alkalinity. The range is in alkaline range, and when your detergent is in the alkaline range, it shows excellent performance in terms of cleaning action, in terms of foam value, in terms of reduction in surface tension. Now, basically the detergent which is being prepared, which is being manufactured in the laboratory, whether it is functioning or not, it is tested on 3 parameters. One parameter, its ability to reduce the surface tension of water. Second, what amount of foam volume it is generating. Third, that which is called percent detergency, that is known as cleaning action of the detergent. Now, we see, just look at the slide, the 0.1% O11, we have taken sample O11, it has reduced the surface tension of water to the tune of 55.05. And the contrary, the conventional surf excel, it is showing reduction. If you look at its, 0.1%, it is showing reduction to the 52%. When you take 0.5%, it is showing reduction of 61%. Likewise, you just compare this surf excel sample. You kindly see this surf excel sample. At 0.1%, it is showing 35.61% reduction. And at 0.25%, it is showing 40.83% reduction. And wherein you check it at O11, it is showing 52 and 61% at 0.1 and 0.25 concentration. Even we have increased the dolomite percent to 67%, 26%. And look at this O14, it is also showing a good performance, even despite of the fact that we have used dolomite. So this particular piece of research tells us there are alternative to the traditional detergents. Now we have tested its cleaning action on the cloth. First was soil stain cloth. Then look at this last, when you compare O11, it was 80% when it comes to 0.1 concentration, 0.25 concentration, it was 81%. And compare it with the surf excel, whose cleaning action was only 72% at 0.25 and 0.1% as 54.18%. Likewise, the dolomite, which was showing initially reduction in surface tension of water, was not appreciable to that extent. But when it comes to a soil staining cleaning ability of this O14, just you see this particular bar, its performance, even at 0.1% concentration, it is showing 83.91% cleaning action. Right? And 0.25%, it is showing 84.84% remarkable cleaning ability. Now, I'm going to see the significance of this particular research as a project. What we can do, it is a farmer-oriented development project, because the country like India, there are many countries in India, in the world, where farmers are committing suicide. This is a very big problem, socio-economic problem, particularly India is facing, because the kind of byproducts which are produced, the kind of main products produced by the farmers, it is not giving them money, and there is no value addition to the farmers' cultivation. This is going to be a very good value addition to the farmers, as we are converting starch glycerol into detergent. It will contribute to global GDP, promotes cleaning industries. Value addition, it converts low value material like starch, dolomite into high value biodegradable product. For instance, we are converting starch and dolomite into biodegradable detergent, and this industry is going to have a financial transaction of $11 billion by 2029. Scalability, job creation, it is going to scale up. It is scalable production. It's going to create jobs. It is in agriculture, manufacturing, R&D, research and development, environmental benefits, because they are biodegradable polymers. They reduce water pollution. They reduce eutrophication. It is going to reduce chemical waste. It is promoting ecosystem health and sustainability. And basically a reduced petrochemical use. And for a country like India, we import 22 lakh crores of petroleum every year. And if such kind of sustainable proposition is being accepted by the industry, then farmers can directly get money by selling out their starch, their glycerol. And it would be a huge transformation of green transformation for this particular in the era of biodegradable polymers. These polymers replace petroleum surfactant, promoting green chemistry, superior performance when it comes to surf excel, low STBP, sodium tripolyphosphate, sustainable ingredients, reduce environmental impact, potential for cost-effective, contribute to farmer welfare, employment and environmental protection. This is very important because it's going to contribute for the welfare of farmers. It is going to give them more money. It will generate employment and it will protect the environment also. It is a step towards a sustainable chemical industry. Vision for the future: integrate sustainable chemistry in the household products, enhance global collaborations for greener technology, create a sustainable, clean economy for future generation. Thank you.